Okay, so welcome to Mathstoria, and let's have this topic. So to verify this identity, these are the steps. So first, we need to work on complicated side. So for this given, we need to work on the left side, then change all functions to sine and cosine using these different identities. So for this given, since we have this cosecant x and cosecant x is equal to 1 over sine, so we need to replace this cosecant x by 1 over sine x because the angle is x, then over for this tangent x, since tangent is equal to sine over cosine, so therefore this tangent becomes sine x over cosine x. Then plus, so for this cotangent, since cotangent is equal to cosine over sine, so therefore this cotangent becomes cosine x over sine x. So observe that all the functions are sine and cosine. Then do the given mathematical operation. So for this equation, we need to simplify this denominator. So we have 1 over sine x, then over. So we can apply cross multiplication for this denominator. So sine x times sine x, that's sine squared x, then plus this cosine x times cosine x, that's cosine squared x, then over this cosine x times sine x, that's cosine x times sine x. Then simplify. So we have now 1 over sine x, then over, since sine squared x plus cosine squared x is equal to 1, so therefore this sine squared x plus cosine squared x is equal to 1. So we can rewrite now this equation as 1 over cosine x times sine x. Then simplify. So we have 1 over sine x times the reciprocal of this denominator, that's cosine x times sine x over 1. Then simplify. So since we can cancel the sine x, so therefore we have now cosine x over 1, or that's equal to cosine x. So since cosine x is equal to this cosine x, so therefore this given is an identity.